In today's lesson, we are going to be looking at going from getting an equation from a graph. So far we've looked at going from a pattern to a table to a rule. We've looked at going from a pattern to a graph. We've looked at going from a pattern or a rule to a table and from a table to a rule. So again, now we're just looking at a different representation going to another. So by the end of this, we should be able to come up with any other representation of a linear relationship, regardless of what other relationship or representation we're given. So that's going to be the goal towards the end of the unit. But right now we're just going to be looking at getting an equation or a rule from a graph. So we want to determine the rule in the form y equals mx plus b, represented by the graphs below. And we're going to start by creating a table to help us, just to kind of see any connections. So if I look at the first graph, I can see that I'm going to have x positions starting at 0, 1, 2, 3, 4, 5. And it is going to increase by more, or there are going to be other positions, but right now I only really need this. And the reason I'm putting this down is because I can clearly see on my graph that I have nice dots or nice points at these values. So it makes it really easy to figure out what the actual coordinates are. So when x is 0, y is 2. When x is 1, y is 4. When x is 2, y is 6. When x is 3, y is 8, 10, and 12. So those are the values from our table, or from our graph, that we just put into a table form. Now, can we come up with a rule for this? And if we look at this, we should recognize some key things based on what we've done so far. But we should recognize, again, where our constant is. One, in our table, we've talked about our constant being when x, or the input value, is 0. In this case, our constant is positive 2. Now there is another place that we can see it, because we can see that constant on our graph. If we go down our y-axis, the point that's on our y-axis is our constant. So that's two places that we can see what the constant is. Next, we need to figure out what our multiplier is. We need to figure out what we're multiplying by. And we can see that in the table because we're increasing by 2 every time. So we should recognize that our multiplier is going to be 2. So our rule then will be y equals 2x plus 2. Now again, we've seen the plus 2 from the table before. We've seen that in previous lessons. Where do we see that in our graph? Well, we see that in our graph because we can see it as I go over one position, I'm increasing by 2. Doesn't matter what points I look at. I go over one position, I increase by 2. Over 1, increase by 2. And so on. Over 1, increase by 2. So that's where we can see it in our graph. We're seeing how our y values, or how our points are changing every position. So let's look at the next one. Again, we have some nice points already plotted for us. This can help us come up with our table of values just to see the connection, and then hopefully we don't need to create the table anymore. So again, when x is 0, y is 0. When x is 1, y is 2. When x is 2, y is 4. When x is 3, it's 6, 4, and 8, 5, and 10. So again, we want to come up with a rule for this. Now again, we need our constant and our multiplier. From our table, we should recognize, again, our constant is 0 or plus 0. And we can see that again in our graph, the point that's on the y-axis, the value vertically, it's at 0. For our multiplier, again, we can find it in two ways. From our table, when we're adding 2 every time. And again, we can see that in our graph because every time I increase by 1 position, I increase, or my y changes by 2. Increase 1 position, y increases by 2. 1 position increases by 2. So it doesn't matter what set of values I look at, it gives me the same thing. I'm increasing by 2 for every 1 position. So that tells me my multiplier is 2. So then my rule is going to be y equals 2x plus 0. Again, I don't need to show the plus 0. I'm just putting it here just so we can see the connection between the rule, the table, and the graph. So what do we notice that's the same, and what do we notice that's different? Well, if I look at my 2 rules, we can see that the multiplier is the same. The multiplier in both cases are 2, so they're both increasing at the same amount. So you could have that in there as well. What's different is that they have different constants. Different constants, one starts at 0, one starts at 2. So again, that's what's different between them. Other than that, they're relatively the same. They have the same multiplier, so that means they have the same slope, same rate of change. So nothing's changing there, same steepness. The only difference is where they start. Can we make any connections between the multiplier and the table or graph? Well, the multiplier is what it increases by for every 1 position. So what it increases by for every 1 position. Oops. And for the constant is our y-intercept. Or you could say the point on the y-axis. So again, that's kind of the connection between the graph and the constant and the graph and the multiplier. So we're going to use that to help us jump directly to the equation from the graph. Now, as a little bit of a summary, there are some things that we want to keep in mind and just kind of reiterate. So as a summary, to determine the rule or a rule from a graph, we need 2 things. We need the slope of the graph, and we need the y-intercept of the graph. Again, the slope is our m value, the y-intercept is our b value. So to find the slope, we need 2 points on the graph that are on whole number values. So the key thing is 2 points and whole number values. The reason we want whole number values is just to make it easier for us to read the actual coordinates. If we're looking at points that are halfway between lines or things like that, we may get an inaccurate multiplier. So we need to determine 2 things. We need to determine the rise, which is the change in x going up or down, and we need to figure out the run, which is the change in x going left or right. So we see a diagram over here to the right here. If I'm looking at 2 points, I can look for the rise, which is telling me how far up or down I'm going to the next point, and then the run, which is telling me how far left or right I'm going to the next point. The directions tell us in terms of the sign. If we're moving to the right, that's a positive direction, so it's positive. If we're moving up, that's also positive. If we're moving down, that's negative. And if we're moving left, that's also negative. So just some kind of key things to think about. And the reason we find our rise and run is because that's going to tell us what our slope is. So in this case, our m, or our slope, is going to equal rise over run. So now we have a new definition or a new term for our m, or our multiplier. And we will kind of look at this, but essentially we were looking at rise over run And in every scenario, the run was 1 because we were looking at the change of one position. So now this rise over run formula allows us to find the slope or the multiplier for any 2 points on a graph. And we'll look at an example of how that's used. To find the y-intercept, determine the y value at the place where the line crosses the axis, or the value of y where the line crosses the y-axis. And this is the y-intercept. So again, we look at our y-axis, which is the vertical one, and basically we go straight down until we see our point. The y value is our b value. So in this case, our b value would be -2 in this example. So the y-intercept tends to be the easiest thing to find from a graph because it's the one point you're looking for. Rise over run might be a little difficult, but hopefully with enough practice you'll find it relatively straightforward. So let's look at some examples. So we have 2 examples here. We want to find the rule or the equation for each line. So if I look at A, the first thing I want to do, the easiest thing, is I want to find the y-intercept. The reason I say it's the easiest is because all I have to do is just look at my y-axis here, and I'm just going to go straight down until I hit my graph, or my line, and I can see where the line crosses. So that there is my b value. So in this case, my b value is -2, because that's the y value of that point, -2. Now, for my multiplier, I need to find 2 points. The nice thing about the y-intercept is that it counts as 1 point. So now I just need to find another nice point. So if I look along my graph, I see a couple nice points. I see one here, I see one here, I see one here. And again, by nice points, I mean points where I can clearly see that they cross a grid line, because that's going to help me when I'm counting or figuring out my rise over run. So I can use any 2 points. Doesn't matter which ones I want to use. Let's use the y-intercept. Or actually, we're going to use another point other than the y-intercept just because I don't want to mess it up, or just kind of make it a little clustered around there. So let's use this point here, and let's say, for sake of argument, I want to use this third point. So I start at this point, and I need to figure out what is my run. And basically, how far, what I mean by that is how far left or right do I have to go to get to my next point? Well, in this case, I have to go 1, 2. So I have to go 2 to the right, or in the positive direction. And now I need to figure out my rise. So to go to the next point, I have to go up 1, 2, 3, 4, 5, 6. So I have to go up 6. So that means for my multiplier, if I use our new formula of rise over run, my multiplier is going to be 6 over 2, which I can reduce to 3. Now you may have said, well, why did you use those 2 points? Why didn't you use something nicer or something different? And that's fair. I could have used other points. I could have used this point in the middle, and I could have gone, if we want to do it in kind of reverse, I could have gone up 1, 2, 3 over 1. It would still give me, if I do a small separate calculation, m would equal a rise of 3 and a run of 1, which would give me 3. So rise over run doesn't, it eliminates the need to look at every single position or have every single position. Because in some cases, depending on what our multiplier is, we might not get to see every single position. So the rise over the run from key points allows us to kind of eliminate the need for every single position value. You might also say, well, why did you go from the left to the right? Could you have gone the other way? And I could have, So if I went the other way, starting at the top and working down, I would go down 1, 2, 3, 4, 5, 6. So I would go down 6. And I would go to the left, 1, 2, or negative 2. If I go back to my formula, negative 6 over negative 2, and if I simplify that, I end up with positive 3 anyways. So regardless of which way or which direction you go from whichever point to whichever point, you're still going to get the same value. So you can see we did it 3 different ways, and we still got the same slope. So again, it doesn't matter which points you go to or which direction you go. As long as you do it correctly, you will get the same value. So I'm just going to erase this negative one just to kind of avoid clustering it. So now that I have my m and my b value, I can write out my rule. Y equals 3 is my multiplier, x minus 2. So that is the rule for the first graph. For the second graph, we're going to do the same thing. Come up with an equation or the rule for the line. I'm going to start with the b value. That's the easiest one first. So I go down my y-axis. There's the point that touches the line. That's my b value. So in this case, the b value is positive 3 because the y value of this point is plus 3. Or you can see it touches the y-axis at plus 3. Next, we need to figure out our multiplier. So here, again, we have one key point. Let's find another one. There's another key point. Again, it crosses the grid nicely. I can easily see the values of where the coordinates of that point. It falls nicely on a grid. I could choose, say, another one here. I could choose these ones in between, actually, if I really wanted to as well. So again, if you're ever hesitant or unsure, oh, does it cross nicely? Look further down the line, see if you can see one that's a little bit nicer. Because again, as long as we're using rise over run, it won't matter which 2 points we use. So I'm going to just pick 2 points and figure out what the rise and the run is, going from one point to the next. So I'm going to pick these 2 points just because it gives me a little bit of room to work with. So from going from one point to the next, I go over 1, 2. So 2 in the positive direction. Now I go 1, 2, 3, 4 down. So that's minus 4. So now when I go for my slope or my m value, new formula, rise over run, equals my rise, or the vertical change, is negative 4 over the run, which is positive 2. So in this case, my slope is negative 4 over 2, or negative 2. This does make sense because we can see our line is decreasing, so it makes sense that we have a negative slope. To create my equation now, all I have to do is input the 2 values into m and b. So I know it's going to be y equals negative 2x plus 3. And that's my rule. Because again, all I need to figure out is my m and my b value. And so we talked about we just showed how to find that from our graph. Oops. One last example, example 3. Determine a rule that represents, or that this line represents. So again, we want to look for 2 things, the b value and the m value. M, we now know if I'm looking at a graph, I can use the formula rise over run. I'm going to start with my b value first. That tends to be the easiest. I'm going to go down the y-axis until I hit my point, and that's my b value. So the point is at 3, so my b value is 3. To find the slope, I need to do rise over run. So I need to figure out what is the rise and what is the run from one point to the next. Now this graph has already neatly shown me some nice key points, so it doesn't matter which two I choose. I'm going to choose these two. It's easy enough. There's enough space. So to go from one point to the next, I'm going over or to the right 1, and I'm going up 1, 2, 3. So for my formula, the rise, or how far up or down I'm going up 3, so positive 3, over a run of positive 1. 3 over 1 is just 3. So in this case then, my rule is y equals 3x plus 3. And that's the rule. What rule would have a line that has the same y-intercept but a different steepness? So now here, for this one, there's many answers that you could come up with, as long as the idea is it has the same y-intercept. So that means your rule should be y equals something x plus 3. And you can fill in whatever you'd like into this box. Any number would work, as long as it's not 3. So any number works. 1, 4, -4, a half, 2/3. They're all different slopes. The key thing is just the same y-intercept. For 3, what would happen to the line on the graph above if the rule changed to y equals 5x plus 4? So that means going from y equals 3x plus 3, we change that to y equals, we have our x there, we now are saying 5x plus 4. So what happens in these two, or if we go change it from one to the other? Now, there's two key things we want to look at. Again, the m and the b value. How does the slope change? How does the y-intercept change? So our slope goes from 3 to 5. So it's becoming larger. And again, we talked about in previous notes, a larger slope means steeper. So if we look at our rule, or at our options, we have two that have a line would be steeper. So no, it has to be either B or C, because it definitely is getting steeper. So we can cross off the first one first. Next, we're going to look at our y-intercept. We go from 3 to 4. So we have a larger y-intercept. Oops, keep it color-coded. A larger y-intercept, which means we start higher. So if I look at my rule, or my options, would it be steeper or would it start higher on the y-axis and be steeper? It would be the third one, because we know from looking at the two rules that it will be steeper and it will start higher. So it needs to be the one that has both. So again, the main takeaway from this lesson is understanding how we can go from a graph to a rule. Again, we need to look for the y-intercept, which is just going down the y-axis, which will be given to you in the graph, and then finding the rise over run. So you're finding two nice points and figuring out how far horizontally do you have to go and how far vertically do you have to go from one to the other. And then you're just using rise over run to create a fraction. You can reduce that fraction or divide to get your final answer for your slope. So again, by the end of this, you should be able to now go, when given a graph, come up with a rule or an equation that represents the graph you see.